have a background in videos, also for yeah. Now, before most of the anything activity, practice, let's say image video. If private, I can see the world every time in a video. And if I'm in life, I can do random for as well. I can create type of data. So it's one another AI and if video found if images, I can do CNNs, UNS. I can do like tomorrow. Uh, I can do diffusion models. If I am on the, I see at the time series, I can do LLM, and maybe code. If I see it as like a video, I can do all one video. If I see it as other video, I can do all material. But the problem is, the architecture is on built on category defined by human, not by nature. If from familiar is machine learning, I see it as stability. If I'm a human person who have income images and model life, and all of this is good, and it can have now. We know that stability can be tested, and stability what we do is generate the and stability in the people start now use text, see video, image, control, and everything at the same time. Yeah, and if you have to I can I do it is the second and activity what is that? Is that this activity is a focus. Activity will do a focus on what you want. And when I say that, and ChatGPT is not ChatGPT, what we can now and video and images in one type of context. The different type of content when you are using Gemini, you can now use text, you can now all different that now be project by one tool. So all you kind of on top of the on and this all for this is so we can capitalize on that. So we can have text, video, and then we can can and our our goal is not but not one company with generation. I speak about intuition. have different information in this language. And we can speak about the language. The next language, we have to decode this language. Some people can, I can say, some people can speak English, some people speak, speak, speak French, and as speak another language. But they all tell something on this location to decode these languages. And when you have the data, you have a second of this information over the time. It is the time series. And when you have a sentence, I go to market, it is the sequence of this information. So what to do? We only focus on localization of the data. How we localize the data. And after saying about here, we have the beginning and the beginning of something else. And we can also show the beginning of all satellite data. And it is what we call the sequence token. And we have continuous data. When you add the elements, you have token because you have characters. But here is the only thing is different. You have continuous data. It has actually you understand like this the tokenization related in the first iteration of the product, we want to make it simple. We use the tokenization like the continuous data, like what Sentinel-2 give us and what Sentinel-1 give us. And if we had Terraform give us, anyone if it well, we have the class this step. So what we can do is our example move to see if with this technique we can detect crops. We can see if it is maize, if it is wheat, or if it is other crops. And if we unlock this, we can know that we can represent satellite data in this way. So it can be a different way to see the to see satellite data and to incorporate this in the GPT stack. Yes, and what we do is we align these tokens, and at the end, like the LLM do, we uh, we make an end of tokens. And to make a clarification, when you speak with GPTs does not know texts. All of this is numbers. It is the same way on satellite information. It is all about numbers. And this is an abstraction. And what is the benefit of this, representing satellite data as this? We see that when we represent as this like this, you see the temporality. The temporality is preserved, and the temporality is very important. And you you can do the fusion of lot of modalities like MODIS, like Sentinel-2, like Sentinel-1, and you can manage irregular sampling because you know that the temporal resolution of Sentinel-2 is different than the resolution the temporal resolution of Sentinel-1. And you can integrate those spatial contexts. You can integrate the longitude, the latitude, everything you want. All metadata, you can integrate it. And you can do prompt. You can do whatever you want. And you can add taxes on it to train your models. And this, and also multitask. You can do in the same modeling, do multitasking to know the crop. What is the crop? To forecast the yield and to tell something about the climate. Yes, and it is not an alternative. It is a generalization. We want to have a general representation to make this, to make this modelization in the same way of the GPT stack. And the GPT, the T of the GPT is transformer, and it is the model published by Google, and the base model of all of the advancement of AI in the recent 5 years. Yeah, yeah. Why tokens are essential? Taxis can be tokenized, images can be tokenized. And we see that in the beginning, only taxis was in the GPT. And after that, researchers at Google published VITs. And it is an intuition and inspiration in in the transformer where they tokenize images. And this unlock the fact that now GPT can see and all other model can see. Audios, audios can be tokenized, videos, codes, genomes, robotic, and the common point is everything is tokenized. And now we can tokenize also in this way. In this way, in the simplest way, we can tokenize the satellite data. Yeah, yeah. Until now, no Earth observation format naturally fit the GPT paradigm. Yes, we have lot of studies in remote sensing who try to do tokenize, who did it, but not in the way of GPT style, because they did tokenize, because they tokenize in the other ways, and they use like mask auto encoding, but not regression. This uh, this auto-regressive technique used by GPT. And also, the way we tokenize it is very different with what they did, and more simple. And with our representation, Earth observation became a natural modality. And now this modality can be added in the GPT format, in the generative. And what, and here, it is a model we use. It is the GPT stack. We change nothing. Our work was on the abstraction of on the data, how we can represent the data to train a model who can do multitasking. And was this is our thing. And what we do is every we have the time step, we train and we predict the we predict the next time steps of all the other satellite, and at the end we will predict the class of the crop. Yes. In this study, what we were testing is just crop classification to see if it worked before going at scale. And that is our result, and it is in the pastis data. We see that our model here do a prediction, do good prediction on crops, and in the benchmark we see that our model is must have less parameters, but have must to have better accuracy. Quiz as a model which have lot of parameters, and we see that also in the foundation model. In my left, we see that on the foundation model, our model, which is not a foundation model, have a good accuracy, and we have a more smaller models. And why it does, why does it work so well? Because Earth observation data is fundamentally sequential. It is multimodal. We have lot of modalities, lot of products. It is irregular. The temporality is not the same between products. It is noisy. It is heterogeneous, and it is partially observed. Yes, and these are exactly the situation where transformers shine and do good things. Yes, and in the conclusions before the perspective, Our conclusion was satellite data are images, time series, and videos, tabular data, and now tokens, the universal language of GPT models. And after that, our perspective now, we are working on doing a foundation model on it with the next token prediction to have a foundation models which will incorporate lot of products, climate, optical, and radar data. Also, we want to integrate natural language. We speak with the maps, speak with the map in a GPT ways. So do the forecast. Tell me what is it. Why? Tell me why the precipitation drops, etc. etc and and the large self-supervised learning. And, and, and this large scale self-supervised learning will be do exactly how GPT does a training with the next token prediction. Here we will do next, uh, you have to do the next step prediction, next date prediction. And this after that, if you can do that, you can do uh, forecasting and any way you want. Donc, this is what we are doing right now. And thank you.
Thank you so much, Doctor. We have time for questions.
So if your last proposal, you mentioned that you're thinking about a foundation model where you would, I guess, talk to the map and ask it, what is the rainfall tomorrow? Do you think this GPT-like sort of framework could eventually be used like for forecasts, like in the sense that you could, again, just looking at tokens of images and things like that and asking what's next? Could this be a potential approach for forecasting as well? Rainfall, for example?
Yeah, I think that it can and be, and what we want to do in the next, I forgot to mention it, is we want to incorporate spatial information. So spatial embedding, we can add a lot of pixel information on it, and we can train on next step prediction. So we can have a lot of information, and we can say, uh, you can your goal is to predict the T steps. So it can be done, and it can predict the precipitation. But if it will be very very good, I don't know yet, but it can be tested, and it is something we want to test, but not for only precipitation, but in the run rate. And the objective is just to have foundation models, and these foundation models, everyone can use it to the with whatever he wants.
And lastly, can you say something about how long it took to train it and in terms of the compute resources you
Yeah,
had to use?
yeah, yeah. Thank you. It we use a 16 giga GPU in this model, and we use only a small data set, Pastis R. But we had a limited resource, resources, computing resources. That's why we cannot now do the foundation models. Foundation models is need lot of computation. Donc, and we don't have this compute, and now we try to find it and to train at scale.
Okay, thank you for your presentation. My question is that maybe follow the previous one. To train your model, if you are using the pre-trained model from foundational models like Hugging Face, the data trained in another place like US, how to adopt in local area like here in South Africa or South African region.
Yeah, a nice question. Yeah, what we do in the paper. So when you write sheet deco, you can see the paper, and the paper. When we train this model, we can do few short learning in other region. So we train in some region in France, and we add some data, and this model goes well in other region. So what we can do is when we train the model, we can do few shot learning on other region to adapt to the model and to have good accuracy.
Okay, thank you for the presentation. I'm just wondering whether you apply this model for some sort of local task, maybe in some of the African countries. I don't know whether I missed this, but you didn't talk about it during your results. So.
Yeah, not right now. Right now, we use just the Pastis app. It is in France. It is the data set we see with we would have the modality Sentinel-1 and the modality Sentinel-2, and which is temporal. But it is a perspective to have globally, to train globally. But right now, it is just this data set with 15 gigabyte we train, and it is in France. So we have to do a global training or in Africa. But right now, we did not do in Africa.
All right. I think we're good in terms of time. Thank you so much.
Thank you.
All right, so our next talk is going to be by Fatwani, who's a researcher at the Agricultural Research Council and the University of Pretoria, and he's going to tell us all about drought prediction. Please, Fatwani. Yeah.
Good morning. Like she already mentioned, my name is Fatwani. I'm based at the Agricultural Research Council, and I'm affiliated with the University of Pretoria. And then, yes, I'm a student researcher, not really a researcher. So, yeah, to correct that, because you might miss employment someday because of that. Yeah, so I'm gonna actually talk about application of some algorithms in our sector. I'm not really a model developer like the previous speaker. Those ones, they build model from scratch. I use algorithms that are already existing. So on this work, I work with Professor Emma Acker and Willem Landman, both from the University of Pretoria. You saw him there on the first day. And then we have our beautiful lady, Dr. Masupa, that is also my supervisor at the Agricultural Research Council. So the study that we are conducting is actually funded by the Department of Agriculture through the DALRAD project. So they're trying to address issues around drought in the Karoo region of South Africa. So this is just part of a very big project. So even on my work, I just took a portion of one of the objectives that we're trying to address. So this is actually the Karoo region of South Africa. The points that you see there that we picked include Prieska, Williamstown, and then Beaufort West. Then we have Middelburg in the Eastern Cape. So the reason I put on a picture there on the right is just to give people an idea that are not from South Africa or have never been to the Karoo. That is, most part of the Karoo looks like that. So you can tell that it's not really a good environment for farming. Then that's why the Department of Agriculture is trying to address whether is it good to continue farming in this region or not. Then when you advise them, you must bring in some proof of what is happening. Currently, yes, then we thought of adopting AI as part of the models, which we can maybe refer to prediction of drought. So the Karoo region of South Africa, you now already know where it's based. Then we have some rainfall patterns in South Africa. I'm sure you saw a lot of rainfall in the past few days. And then someone can say that, okay, it's fine, you're talking about the Karoo, but South Africa is experiencing a higher amount of rainfall. Even some parts now, let's say, for example, the KwaZulu-Natal part, they're even experiencing flooding. But if you remember yesterday when Dr. Namo was talking, he mentioned that drought is an area that needs a lot of research, because the moment you experience drought, then you're going to affect all sectors. It actually put problems on food security. Yes, the eastern part of the country is expected to receive a lot of rainfall and a lot of flooding. And then we have a lot of uncertainty there. Then I remember Prof. Namo was also there in Lusaka when we were attending the WaterNet. Professor Francois Engelbrecht presented a model of high uncertainty in the eastern part of South Africa, wherein we are expected to receive a lot of rainfall. But we have that region in the Karoo, so there is nothing that is happening. Even the past few days when the most part of the country was receiving huge amounts of rainfall, the Karoo region was not receiving a lot, and most of part of it received less than 180 millimeters of rainfall per year. So you can tell that that is also an area of concern. So what are the main objectives of this part that I'm going to talk about today? We are planning just to develop models for drought predictions based on historical climate data and drought indices from selected stations, which I've mentioned in the previous slide. Then we are also going to evaluate the predictive performance of the models across the selected stations, utilizing some validation metrics, which include the root mean square error, the mean absolute error. Then we also choose the coefficient of determination. So this is the evaluation approach. I just used some form of AI to create this. And then I always tell people that, yes, I will actually utilize it at some point, these AI models that most of you are trying to build. So this, for me to create that flow diagram, I used what we call napkin AI. So that is part of AI. I just write down whatever I want on the flow diagram. Then that's why it's beautiful like that. So we actually use the historical climate data. Then we are also computing the PET. Then we calculate the standardized precipitation evapotranspiration index. Then we went on to do some training. And then after training, we do the prediction, and then we evaluate the performance. Then our target variable on this, it was the standardized precipitation index at seasonal level, wherein we had also the predictor variables from our weather station data. The data that we used for this is the weather station data from the Agricultural Research Council. So our input variables was rain, temperature, potential evapotranspiration, and then we also have relative humidity. Then we had some of the metrics scores. On those metrics scores, I know that is a very large table. I just included it, everything, even though I will just show maybe the predicted and observed of the summer season, but I just decided to include all the metric scores so that you can be able to see that the model that performed better was the long short-term memory system, And then we also have the random forest that did try to perform a little bit better. Then the support vector machine was the least performer of the models according to the metrics that you are seeing on the board there. Then when you are talking to farmers or someone that is not really into this, you have to also do a visual representation of what you're talking about, because you can say metrics, you show numbers. Then I went on to say, okay, it's fine. Why don't I do an observed versus predicted spay over Beaufort West? And then I also did the one for Willingston. So on the models above, you can tell that the long short-term memory system is the one that is close to the observed, and then the support vector machine is the least performer, because when we check the predicted and the observed variable line there, you can tell that it's very much far from the observed. The observed is in the black, and then if we check the red line here, I'm not sure. Yeah, if you check here, you can check that the support vector machine was very far from the red when it was actually predicting some of the extremes. And then if you check here, the long short-term memory system along the graph, it performed a little bit better. The same case to Willingston, but in Willingston, all the models almost showed better for performance. Yes, I know that here, if you check the support vector machines, was struggling a little bit. Even the long short-term memory system, there were situations where it was struggling, but overall, it was the better performer across the models. Then I also had to do a residual plot in order to actually see which model was actually very far from the observed. So if you check here on the red one, is the one that is very much close to the dashed line there, the 0. So which means that this model, the moment you see a model being closed to this observed, it means that it shows great performance. And then the support vector machines in the blue there, it is very far from the 0, which shows that it was the least performing model. That was the same case for Willingston. If you check here, the support vector machine was the one that was not performing well. And then the long short-term memory system in the red there was the one that showed great performance. This study is not really something that I just woke up and decided that I want to do. I looked around and actually checked some of the literature. Then I found that there are many people that are doing this similar work. This guy, they did some rainfall prediction using some of the models which were in the multi-perceptron model was the one that performed better. This study was done last year. It was done across Nairobi and then Pretoria, and then they have some Abuja and the other areas, including Cairo there. So these guys, they just compared the models to see which one is better in predicting rainfall. Then they found that is the multi-perceptron. So by this, I'm just saying that people are really trying to dive into the use of AI for better predictions and better planning. So I think it's good for young scientists like us to actually try to dive into it. Yes, it requires a lot of skills and then a lot of things to consider when you want to dive into things like AI, maybe some programming skills of which if you are not really equipped, you might have to first learn. Let's say, for example, when it comes to building model, like I said, I cannot build models, but if those ones who build models, they refer a better model for us to build, then we can use such a model for predictions and better planning. Thank you very much.
Futuwana, thank you. Great presentation. Question is, and it's something that we battle every day with. For example, the Western Cape, where you have fronts coming in, we tend to find that the forecasts are doing better, specifically on rainfall, because it's a front that's coming in. In other parts of the world where we have thunderstorms, we know that you can get 25 millimeters and 5 kilometers away, nothing. So my question here is, unless you have a very dense, let's call it population of measurements, the data can be very skewed in terms of the observation versus the forecast. Because the weather station, I assume the observations was done by weather stations. It might just happen that that weather station was outside the thunderstorm. So how did you compensate for that?
Okay. When it comes to that, I didn't really want to do too much detail to that. And then, yes, you're mentioning some good points. Mostly when you do predictions, say, for example, you mentioned that if you have a signal, then it becomes simple to predict rainfall. Let's say, for example, for those who predict drought, it can be a little bit difficult in the neutral season where you don't have a signal. Maybe in the La Nina season, it can be better because you might know that it's going to be wet. In the El Nino season, it's going to actually be dry. So coming back to your question, yes, it's something that I should consider, and then I didn't really compensate on that. Thank you.
Amazing. Thank you so much. I think, yeah, we're a little bit tight on time, so thank you so much again. And, right. For the next presentation, I'll let you plug your laptop in. So, of course, you're going to notice that I'm going to be a bit longer for members of the AfriClimate team because I know most about their background. So next up, and to close the round for researcher lightning talk, is going to be Amel Namouchi. Other than being a co-founder of AfriClimate AI, which started 2 years ago, she is now wearing the hat of the CEO of Watso, an energy startup making big impact between Sweden and South Africa. And we're going to hear all about it in a second. Thank you. This I guess we don't need. Yeah, I'll take it. Okay. You can just extend the screen on the screen. Okay. You don't want to see that.
All right, perfect. I see we're short on time, and it's the last kind of talk before all the talks, I think, AfriClimate AI. So my name is Amel Namouchi, like Sabrina mentioned. Over the past 2 days, you've known me wearing the hat of AfriClimate AI, so now I'm going to take that out. And way before AfriClimate AI, I've been smart energy specialist, been doing both research and work on that, and that led to my latest venture, Watso. And yesterday, Miguel talked a little bit about doing the demand forecasting from the operator point of view. But when we have the transition towards the energy market, the end users as well, in this case, we usually talk about IPPs, independent power producers, they also need that kind of intelligence. So whether demand forecasting or renewable energy forecasting for their scheduling, etc. And that's what all Watso is about. So first of all, I'm going to take a step back and talk a little bit about the context and why this matters. Biggest reason why this matters is that our grid is changing. And we used to, well, it's still the case in many African countries that we talk a lot about centralized grid or centralized systems, but we're slowly transitioning towards distributed energy systems. And this was enabled because of the massive integration of renewable energy, right? the thing is, if we only have massive integration of renewable energy without an energy market, that brings us a little bit stuck in what we call curtailment. So in many cases, I don't know if you hear me. Okay, this is maybe better. In many cases, we talk about curtailment, and what this means is that we could have produced some power, but we did not because we simply did not have the infrastructure. And in the other case, while consumers are suffering from outages or load shedding, we, on the other side, the generators are curtailing their energy generation. And that's why we need energy markets. And what that means is we're transitioning from being consumers to being prosumers. We both consume and produce energy and exchange it through the grid. So the grid is not the only producer and giver of the energy. And this is good for everyone because the grid alone cannot really keep up with the increasing exponential load or demand. And that leads basically to unstable grid and so on. And the need for the IPP in this case is very crucial, but they need intelligence in that case, right, to operate their energy management and so on. And the last one is the need for the green energy transition. And the energy itself, I think it's the second or the first field contributor, or the electricity contributor to the CO2 emissions. And lots of companies and businesses, they have a mandate of transitioning towards green consumption and so on, but their grid is still not that green. So through the wheeling and so on, for example, that we have in South Africa right now, they can use that to enable their green energy transition. So Watso is basically the energy platform that helps clients, IPPs, and businesses in this specific case, because in many countries, the households still cannot really participate in these energy markets. So our focus is in that, and we help them basically cut their costs, operating in a more optimized way, and accelerate their green transition. Using, of course, AI, different monitoring analytics, and in many cases, scenario simulations, because a lot of businesses, they still don't have solar energy or batteries, and they're interested in simulating those scenarios. And that's where the projections of the climate or of the weather over until 2040 and so on really helps with these different scenario simulations. And in our case, we do the forecasting hourly. It's over different time horizons, 6, 12, 24, and 48 hours, depending on the energy market. But the most common one is 24 hours. And to break it down to what we do is, the very first one, of course, is real-time data insights. Lots of businesses in different countries, they still don't have insights about their own consumption, about their own production, and so on. And one of the reasons is really we don't have smart meters, but there is now slowly integration of smart meters. And South Africa is actually leading in that. When it comes to Sweden, we have 100% integration of smart meters. So that really enables us to be more efficient when it comes to that. The second one, okay, once you have this real data insight and monitoring, then it comes to the energy forecasting. We want to forecast our demand, and we want to forecast our renewable energy generation. We have a big focus on the solar generation at the moment. And the third part, as I mentioned, is the scenario simulation. It's what if scenarios. Okay, if my pathway, zero CO2 pathway is 2040, what if, like, and this is my consumption, this is my production, can you do projections for me to install batteries and so on? And this basically is to enable the energy transition for these different businesses. And we do that also, we enable them to do these different things themselves in a very easy way through large language models, but integrated with the system. I'll just do a very quick demo on this. This is our main product over a grid. And basically here we have the energy forecasting on different forecast range, as I mentioned, 6 hours, 12 hours, 24 and 48 hours. And on the side, you see weather scenario that's still grayed out. And that's where we really need more weather data at, because our clients and pilots are really interested to know the weather impact on their decisions. So say I scheduled, the next 24 hours, this is my schedule, this is what I'm gonna do, store X, export X energy or import X. But because of the intermittency of nature of the solar panel, the generation and the weather, those schedules are not always perfect. So was it the machine learning model that was really bad, or was it like, the weather forecasting? Yeah, so that has been really big interest. And of course, for these different demand, we use weather parameters. A big focus on solar irradiance and different types, but it really extends to more than that. Here we really have the metering. These are different sites here that we have. So it enables the client to see the their different portfolio in terms of consumption, generation, comparing really different sites because they're interested in the hard to ablate sites, and then the environmental impact. And then these are different features, okay? It's more analytics, but the most important one that I wanna show, maybe, yeah, some actually, some sites, they still don't have that many data, but here with Chart with your data, that's like where they are able to generate their what-if scenarios. In Sweden specifically, there is a big focus on the EV. So what if I charge my EV at this time or that time? But for businesses, it's more focused on battery. And these three different ones is where it comes to the optimization and the wheeling, the scheduling for the next day ahead, etc. So coming back to this, yeah, so I'll just focus on South Africa at the moment. So for the South Africa, we've been, I think it's a very exciting time for South Africa when it comes to the energy market, personally. And one of our pilots is Equities. It's a property fund company. And we've been really lucky enough to work with them. And so far we have covered over 70 or 80 sites. So we have access to smart meters and inverters from these different sites to be able to do the different scheduling. And coming back to that, why South Africa specifically, you can see from this map, this is the smart meter adoption 2020-40. Up north in Sweden, that's 100%. If we go a little bit south, as usual, we don't have much data on the African continent, but we always see, South Africa, there is an increasing adoption of the smart meters, and this is really, a big plus for us to work here. And of course, for us, smart meter is the equivalent of weather stations. So we need the smart meter to be able to have the energy, the energy and load data, but also we need the weather data to really achieve this efficiency that we want to achieve. And what I want to say is, we usually say, okay, Africa is energy poor. We have big problems. Lots of people don't have electricities. Our grids are really not working. Lots of load shedding, lots of outages, and so on, because of this centralized manner. But what I want to say is Africa is weather rich. And what that means is, you can see on that map, like how red it is, it's really an opportunity to enable this renewable energy solar transition to become the opposite. So we really sit under this world's strongest solar belt. But of course, we also have the world's most volatile weather patterns and so on. So we really need to focus on minimizing that risky zone when it comes to scheduling our operations. And for us, we're really constantly looking for partnerships and pilots. This is a big focus on businesses, but we can, on South Africa at the moment, to really prepare them for this this big transition towards the energy market that's going to happen hopefully in April. Thank you so much.
Thank you. That's super interesting. Really, really great presentation. We're also working in energy a little bit, so definitely we should talk more. But also, I'm really interested about the data aspect of it. So you're providing a solution that's wraparound effectively from the generation side, but also using demand side data. How are you able to kind of access that data? Because I would imagine that's quite proprietary, both on the smart meter side as well as on the power production side, and especially for private production IPPs, I imagine they would be quite protective over their power data, given there's a big energy trading aspect probably for them as well. So really interested in how you manage that, how you work with partners on securing their data and integrating that into the solution.
It's always a problem with data. Definitely, it wasn't an easy task. The smart meters and inverters are usually owned by the business, and they are interested in the service. Okay, we have the data, and we are an independent power producer, or we want to become. So we need that data, to provide them with the different forecasting and scheduling services. So they own the smart meters. And actually, one other thing is usually, especially for big prop tech companies where they have many sites or many smart meters, throughout the years, they end up with many third parties. So they have different monitoring platforms and so on. So for us, what we enable them to do is to have this holistic platform to manage all that portfolio of smart meters and inverters in one platform. Yeah.
All right. Thank you so much, Amal. And we're gonna be moving on to a community talk. You can. I'll introduce you while you plug the laptop in. All right. So next up we have John Baglico. He's a co-founder of AfriClimate AI. So I'm going to be repeating that. Actually, there's 4 of us who created AfriClimate AI. John is going to tell us about a really, really cool project that he has been leading with members of the community this last year, I want to say, like almost a year now. And it's about a systemic review of data, like satellite data products all over Africa. So I think this topic is going to be extremely relevant to every one of you. And I'll... Okay. The other way, actually. Yeah. All right.
Good morning. So my name is John Bagiliko, as Sabrina said, and I'm a co-founder of AfriClimate AI. And so before I present this work, I would tell you some suffering that we went through as a group. And before I do that, I will show you the people. So as Sabrina said, about a year ago, we decided to make people's lives easier by trying to bring together different satellite data or reanalysis data in a form of a catalog, so that if you went to this platform, you would get information about what product is good for your location, and for what context, and for when, and so on. And so we created a Google Sheet, and we said, okay, everyone should add something, just look around, find a data set, add it on the sheet, add some information, about the data, the description, where you can download it from, and so on. So that seemed very easy, and we did it with enthusiasm, but there was a column on the data sheet, on the Google Sheet, that no one added something. We all left it blank. For the other columns, it was easy. We filled them up. And so the question was, why didn't we fill that column? And it turned out that we had underestimated the gravity of the work. And the column was for us to give an evaluation of each product based on the location, in terms of Africa-wide or even country level, in that sort of granular level. So I will give an example. If I pick chips as a product, and I want that when the user comes to this catalog, he should be able to get an information about chips, how it's produced, which location it performs well in this sense, also when to use it and what to use it for. So in that short, in that cell, we want everyone to do sort of a review of works that have validated chips across the African continent, and then come to make a summary of it in that cell. So we found that it was really very difficult for us to do, and which required that we had to go back and do what we call a systematic review to then be able to provide this sort of information. So that's what we did. We went back and sort of now try to use a scientifically verified method, which is a systematic review, to be able to fill this. And the objectives were then to ask, what sort of validation approaches have been taken in the African continent? Which products have been validated? What are the temporal scales that people usually validate on? Is it daily? Is it 15 minutes? Is it 1 hour? And so on. What's the coverage? Do people validate on national level? Do they look at the whole continent? And so on. And which products, is it reanalysis data, or is it satellite data that are usually validated, and so on? And what are the limitations of these products? And are these limitations sort of region specific? So in that case, if we can get all this information and complete the catalog, a user then is able to go there and easily, based on this information, to pick a product based on their location and based on the use case that they want to work on. And again, this is the team that has been working on this for over a year now. Actually, before that, so the topic, if you look at the program, it was to talk about community building, right? So I will use this opportunity to just mention something briefly about the team and what sometimes happens. So as a team, we set out together, but sometimes people have different things that they also have to take care of, and so on. So, someone can disappear for a month. It's normal as part of team building. But we go back and bring them back. You say, come back and let's suffer together. You can't leave us, and so on. So it happens as part of the team. But we have kept working together over a year, and we are almost at a stage where we will be presenting something very soon, and people will be able to benefit from the work. So as a systematic review, that's why it's called a systematic review. There's a systematic way of putting together, looking for works that have been done, filtering out what really matters, and at the end, synthesizing the information from the different sources. So we had to make some hard decisions because there are a lot of works that may not sort of necessarily be relevant in what we are trying to do. So we had to define some what we call query terms. So we had to use some keywords such as validation, satellite, reanalysis, rainfall, and so on. And again, there are a lot of variables. We have temperature, humidity, and so on. So we had to ask some questions. What do we focus on? And it was a bit difficult in the beginning to decide what variable we wanted to go with, because, I mean, what people are interested in almost every variable. So why would we choose one over the other? But I think at the end, we realized that rainfall is the most chaotic weather variable. I don't know if you agree with me. So among all the variables, rainfall is one of the most chaotic and very difficult to work with. So we said, let's go with that one. We wanted to increase our suffering, so we chose rainfall. And so that's what we did. So after having the query term, we also had to make a choice about the database in which to search for all the works in the continent. We were focusing on Africa, by the way. So we decided to go with Web of Science and also Scopus. And the reason we chose this is because we wanted works that are peer-reviewed. And it means that the results have been verified and we can rely on them and so on. So that's why we went for those two. And so we made the search in these two databases together. So we had about 427 from Web of Science, and then on Scopus we had about 228 papers coming out from the search. So together we were having over 600 papers. That's a lot of papers. And you saw the team, we are not up to 20. And so it means we had a lot of work to do to go through 600 papers to be able to make some sense out of what's happening in terms of studies and all. Now, so we had to do some screening. And so we removed duplicates. We found 179 duplicates and all. And we also had to exclude based on certain exclusion criteria. First of all, we are looking at works that are done in English. And then they are focusing on Africa. If I say focusing on Africa, I mean at least there's a station in Africa as part of the study that was considered. And they must have used metrics, statistical metrics, so that we can give some values to something like accuracy and so on. And we also needed works that are, as I said earlier, we are focusing on rainfall. So we needed works that have included rainfall. And the time scale, we needed something daily or below. So daily and sub-daily, that's the sort of time scale we were looking at. But there was one key thing that we also considered, which is studies that validations that are done with, you are comparing satellite or reanalysis data with ground truth data. Because what we realize is that some people validate products against other products. For instance, using ERA 5 as ground truth. So we excluded all those kind of studies to be able to then compare in that sense. So in all, after all the eliminations, we now had 71 papers to go through in detail. And so I will be giving you a sneak peek to what we found, but then the details will be in a paper that we are currently working on, and also the product, the catalog will also be published. So I'll just give you a sneak peek to what we found. So in terms of the year distribution, we see really the works started, validation works really started to go up from 2019 in that sense. And 2024 and 2019 really had most of the studies. We don't yet know what will happen by the end of 2025. And yeah. In terms of metrics, we also had to make a decision. Well, we didn't really have to make a decision because from the result, we identified the top metrics that are usually used in the studies. And so we sort of picked the top 10, but here we are showing you about the top 5. And so we see that correlation is usually among the metric that most people use. And we have root mean squared error and so on. So in this way, we are able to compare across, because for instance, we can use correlation in most of the papers. Now, in terms of time scale, and it's not surprising what is happening here, because most weather stations record data on the daily scale. So we did not expect that we will have many validations on the 15-minute scale, for instance, because you then want to compare satellite data with ground truth. So if you don't have many stations or observations for the 15 minutes, that's what is happening here. So most studies were done on the daily scale. Now, there's another map that I would show later, but I just want to say something about this one. We populated every country with with a bonus, and it's because there's a study that claimed to have, included every African country. I mean, on the mainland. So we credited every country with one study. And so that's what you are seeing. But then, as you can see, Ethiopia is really the country in Africa with the most validation studies, and we don't know why that's happening. Are they more efficient, or is it they have more climate issues? I don't know. Maybe it's because they have, the topography of Ethiopia is really complex. And so, even for locations that are close by, they can have very different climatology. And so they really have to do a lot of studies, I guess. And so that may explain why we are having these numbers. Some countries, apart from that one credit, there's no study. We are talking about from 2015 to 2025. Yeah, so there may have been studies before that. Okay. Now we removed that bonus, and then there was one also for just the East African corridor. We removed that, and we are focusing on country-specific studies that we can compare. And so clearly, the northern part, the Saharan area, that does not really have a lot of studies there, and some of the areas around the southwestern part of the continent. And generally, we just have low amount of studies validating products on the continent. So it means that more work is needed for us to be able to give people information about what product to use for what at their location. So for instance, I don't know, is it Tanzania or that country around here? Which country is that? Angola, yeah. So it means we may not be able to say anything about what product to use for for what at the moment. So we need more validation studies on the continent. That's what we are seeing from this. Yeah, this one of the challenges actually is that it's about the names of the products. Same product, people use different names, and some don't specify the version and so on. So we had to sort of look at the parent product. For instance, if you talk about chips, we have chips version 2, now there's version 3. Most people don't yet know about the release of chips 3, but it now exists. And you have the Persian product, which also has many versions, many distributions, and so on. And so that was one of the challenges that we faced. But in general, CHEPS was among the CHEPS, TAMSAT, CMOF were equally sort of studied, and they were the most studied in that sense, regardless of the versions. And so, we tend to think that then it means those products are sort of the most used in across the continent. Yeah, and here we can see clearly if we are looking at the product in that sense. I'm surprised that we now have we have 10% equally, but now we have different. Yeah, this is something we have to check, as I said. So there's a lot of resolutions that we have to make to the product and the version. So the numbers may need to be adjusted a bit. But here, CHEPS is the most studied on the continent, followed by TAMSAT and Persian. We also look at the different metrics and try to compare them. But again, not every study used all the top 10 metrics that we are looking at, and not every study looked at all the time scales that we are interested in, that is daily and sub-daily. So that's why we are seeing the gaps in there. But in general, if we pick, for example, correlation, we see that apart from the 15 minutes where you have some 0.87, which is a bit intriguing for further inspection, the correlation seems to increase as you increase the time scale. So if you move from hourly, correlation increases as you go to daily, and so on. So the 15 minutes is a bit surprising as I stand here. So that's something that we need to check. And so, yes, these are some of the things that we are able to show. And people can then look and be able to make a decision. But again, this is everything together. So it's really smooth out. And so maybe you would want to go into the granular level. So here I'm showing a dashboard. Sorry. So this is the idea, to finally be able to allow users to be able to gain some insights, looking at different areas and what products or metrics are used and what does that mean in terms of the different products, and then you'll be able to make a decision. So this is the end goal. It is yet to be finalized, and so we hope to release it soon so people can use. As I said, this is just a sneak peek of what we will be showing. We attempted to provide some recommendations in terms of the different things. For example, daily rainfall monitoring. We see that RFE and CHEPS are sort of the most recommended. They're recommended for those kind of studies. When it comes to seasonal, monthly, TRIM and CHEPS are, again, we think these are recommended for those areas, and so on. So at the end, people will be able to make a decision based on what they intend to do. So in general, we found some issues that were recurring, and one of them is underestimation. The satellite and reanalysis products tended to underestimate rainfall amount. They sort of smoothing out the variability, and so there's a lot of underestimations, especially for the extreme rainfall events. This is usually, I think this is already known in the climate area, that as you increase the time scale, the performance tends to be better. So if you have 15 minutes, usually you have less accuracy than if you increase to daily, monthly, and so on. And of course, out of the underestimation comes the poor detection of heavy rainfall events. And generally, there is bias. So generally, this is also known in the field of climate. So what is next? So I think it would be to complete, the synthesis of the findings, to just synthesize everything so people can make decisions with them, and get the dashboard completed and deploy it. And we also have this platform called AfriWiki, where we tend to provide resources for people. And so maybe the dashboard would be published here, to be put here, and other resources such as how to download CHEPS data and so on, how to do whatever. As long as it's useful, we think that it can go here, and we invite people to collaborate with us and contribute to this AfriWiki project. So in summary, we want you to join us in our suffering, maybe. Yeah. Thank you very much.
All right, thank you, John. I guess we have time for one or two questions.
Okay, thank you for the presentation. Just a suggestion on the, when you are doing your initial screening, on the, before your Prisma flowchart, it's more, the reader can understand when you have a table of your exclusion and inclusion criteria. Because okay, when I look at it, I can see your exclusion criteria, but I can't see the things that you included. So at the back of my head, I'm thinking, okay, if these are excluded, that means the opposite is the inclusion. So I think it would be more sound if you included like a table with exclusion and inclusion criteria. Also, did you develop a search code for your data?
Yeah, thank you for the advice. We didn't include that in the presentation, but certainly we have an inclusion criteria and an exclusion criteria, which would be shown on the paper. What was the second question? Yes. So we had what I was mentioning. We have a search query. You know, a query set that contains some keywords that we use to then query the two databases. So yes, we have.
So if you go to the AfriClimate AI website, you can already access the AfriWiki catalog, and there's already some content there, papers, data sets available. And what this presentation, like the systemic review, is going to be included in it. So already if you go there and type rainfall, you're going to have everything related to rainfall, or data set, everything related to data set. And every one of you is invited to contribute to it. So if you have a sample of data you want to submit and make available to the community, a notebook, a tutorial, anything that you think the community should be aware of, you can already submit it. So it's live on the website. Any other?
No, the only thing I wanted to say was that 0.87 correlation in that it's a study out of Algeria, and so I think I've asked Sabrina to have a look at it. But I think actually the reasoning for it, I think, is it doesn't rain much. It looked like, but I think they evaluated one product. But we'll have a look at particularly why that was the reason. But I remember that distinctly.
Okay, perfect. Thank you so much, John. So now, actually, we can move to well-deserved short coffee break. Let's please try to take like 20 minutes max, and then we can come back for the very last talk of this workshop that I'm going to be given. And it's some sort of a dynamic mix of things you have told us, you have built, and then we're going to just look at the way forward together and a few proposals. So I'll see you in 20 minutes here, and then we can close up our workshop. Thank you so much. For those of you who are staying at the hotel, the checkout time is 11 o'clock. So actually now would be a good time if you haven't already checked out of the room, if you want to go up and grab your bags. I think we can all leave them by the reception, or they have some storage room for us, and then we can pick them up after lunch. Thank you. Okay, welcome back, everyone. It's like 11:00. Congratulations on the punctuality. I don't know if you're very excited about this talk or, well, eager for lunch. I don't know. Okay, so this is the very last talk of the workshop, and we thought about doing something to summarize what we did. So it's a like dynamic. We've been building the slides throughout, but it's also about a call for action. So the concrete things that you could do right now and in the coming few days to make some of the discussions already happen. So maybe we start with what's the work you did yesterday. Remember those 2 hours where you were sitting in groups, lot of laughters, and apparently fun. You were building content to inform our policy briefs, right? And again, we're gonna be in touch by email to ask you whether you wanna actively contribute. Everyone here is welcome to be a co-author, as we mentioned yesterday. So remember the matrix you filled at the very end of the brainstorm session? There were like a section quick wins. So what we did this morning is we grabbed everything that was in the quick wins from all the groups and put it here. So if you don't see every single issue, it means we're just like aggregated them, right? So I just wanted to ask anyone and everyone in this room, if you recognize one of these topics from your table, can you please raise your hand? Okay, so we get at least 70% of the room, maybe more because you're still reading. Good, so basically, thank you for contributing to this slide. I'm gonna go over quickly these topics and solutions, in a sense, to the problems we mentioned, because these came from you, and these will probably be part of the policy briefs along with the recommendation. So first one is look for metadata to accompany climate data. I think we all agree that this is a bit of a challenge. And our idea is to actually make those available in the data catalog that we shared earlier, the AfriWiki database. So you can eventually log in, find the data, you find all the metadata, and then it will simplify a lot. So this is work in progress, and then anyone who wants to contribute, of course, can get in touch. Increasing the number of stations has been a recurrent theme, especially for researchers. Emil from Metos has to leave, but they're doing amazing work, and I think a lot of the stations are actually there. We just need more access. The MOUs also are a big part of how to ensure data accessibility for everyone, collaboration, and I think in the room we have a lot of institutions, and the way forward is definitely through this agreement and data sharing policies. User-specific thresholds, also along with the data, the metadata for the data catalog, these are probably something we can work on all together, and they are definitely a quick win. And then stakeholder engagement, we hope that this workshop was an example of such a diverse workshop where you have policymakers in the room, institutions, researchers, industries, and we really hope to be doing more of that in the future, and we invite you to maybe have your own workshop with different representations from different sectors. And of course, API access, I think it was highlighted earlier, but it would be absolutely fantastic if we can generalize the use of APIs to enable more researchers to access, and then the onboarding phase from the data to the start of the research can be shortened a lot, of course, as we know. So with this, we want to introduce a proposal to you, and this came up also from this workshop because we have so many of the interesting and impactful profiles in the room, including the meta agencies and the industry partners. We want to propose a community of practice with everyone present in the room here today to kickstart this. What this means is a platform that's going to enable every one of us to turn AI-driven forecasting into practical climate resilience. This can be they can generate several inputs, but the idea is to form a community where we can work all together on different topics. And the topics, I think you heard all of them. And this will be AfriClimate AI. We can set the stage, and then it's going to be up to you to push things forward. So concretely, what this could look like is through working groups. I think maybe many of you have experience with joining these working groups that can be formed by different profiles from different institutions, right? Imagine we have Met agencies representatives along with industry representative, policy makers, and then all the discussions that you might have started at the table can be carried out through a long period of time and steer towards having deliverables every now and then. So we imagine 3 working groups. The first one would be around operational AI forecasting. So these are really about the integration of AI model into the operational forecasting. As we mentioned, I think most Met agencies on the continent today do not have AI incorporated. Maybe we're starting to discuss it. We're starting to just touch the potential of it. But I think I'm quite confident in saying that everyone is interested in at least exploring the value that could be added by it. And we really propose this working group as something concrete where we can have the test, where we can have some sort of added value that each one of you as researchers or leaders can show that this is actually what I could gain by using AI models. So we propose this is actually about building the AI and incorporated it into the pipeline, and we're going to have diverse groups with people who implement it, people who test it, and then also around the data structure. So this is also about developing standardized QC pipelines. I think we talked a lot about data quality. AI is not very useful if the data that goes in is missing or there's issues. We're very keen on this. At AfriClimate AI, at the beginning, we thought really it's a data issue on the continent, but realized there is a lot of data. It's just that not all of it is ready for AI. And as you know, this is a very sensitive topic, because if you put a data that is misrepresentative or is skewed, the output is going to be quite terrible for decision making. So this is an invitation to also think through QC pipelines, also using AI, because this is a really field where AI excels. Think anomaly detection. This can be as practical as, let's have a sample, let's build something, let's demonstrate input, and then everyone can take back that and test it in their Met agencies. It doesn't necessarily include, bringing things out of the institutions, but rather sharing the knowledge and the scripts that can be made as a baseline, and then everyone runs it at home. So very little framework like that or standards that we need to impose on the Met agencies and institutions, but it's really rather that we build the capacity on how do we develop QC models, which AI models can we use, which baselines can we run like a week from now, a month from now. So extremely practical. And the output of it, we imagine an AI toolkits, evaluation reports, workflow templates of everything I just mentioned. This is something that we could build together. And I think if we have this group with diverse roles, we really can have an output or an impact in the next 6 months or a year, which is, I think you saw with the presentation from John, over 600 papers, we went through it, and it would be almost impossible if you don't have large groups that work together. So that's really what we want to leverage here today with all of you in the room. So that's the first group. The second group is about sector use case. So it's also more about like a little bit tuned toward industry. We really want our models and forecasts to be used on the ground. So think co-design with climate services, with sector partners, agriculture, energy, aviation, insurance, like all the different use cases that we can test and like co-design pipelines around. We could empower decision making in these different industries, hear about use cases, talk about the use of satellite products. I think I heard someone from insurance mention that they use chirps. Johnny earlier was saying that maybe chirps is amazing in certain area, maybe not. This is also something quite powerful that we can discuss and really adapt our work and talk to each other. So imagine what this sort of group could do in terms of communication. Like maybe you have tested something and you already know the limitation of it, someone else is just starting, and that's a huge gain of time. So you imagine the output of this could be sector blueprints, like something to get started with, templates, and dissemination frameworks of how best can we turn the ideas and the research into something on the ground. And I think also a lot of the tables yesterday were talking about dissemination, language barriers, accessibility in terms of technology. How do we best deliver this impact? Do the farmers care about MAPE and RMSE? Do we use a different language? Do we adapt it? And these are the same problems around the continent. It's really not specific to one region. Everyone faces more or less the same problem, and we could build it together. The last working group is around innovation and policy. This is also, like, we talked a bit about the policy briefs we want to get out of this workshop, and yesterday you started imagining the content that would go into it. And I think in the panel we also heard that having recommendations that come out of a group as diverse as this one, with representative from med agencies, from industry, from research, could be quite powerful and is easily, actually is not easily dismissed, right? So this is about the creating of pathways, the developing of policy briefs. Again, invitation extended to everyone who wants to join, no matter if you've never done a policy brief before. We're going to make sure that we have also experts in this group. And then this is also about recommendations. So imagine us together defining the African research agenda for AI forecasting for the next 5-10 years, right? Policy briefs and recommendations that could start something. So we're not saying that we're going to change everything and the laws are going to change, but this could be the first stone, and the first stone could be done by everyone around the continent. So I hope I motivated you enough. Now for the action. We have a form, actually, so to collect your interest, we would invite you to please scan the QR code. If you don't have your phone, or for any reason you cannot access, use this QR code, we're going to send an email with all the links and just a recap of everything. This form is quite simple. It just asks you which working group would you be most excited about, what's your institution, what's your role. Do not hesitate to take part, even if you're not a decision maker, you're a researcher, you're unaffiliated, it doesn't matter. A lot of what we want to do is about capacity building and doing it all together on the long term. So really everyone in the room can join these groups. And no worries, we're going to ask you and do a poll around frequency of meetings, so we keep this as light and efficient as possible. I'll leave it up for a minute since I see you still taking pictures. Actually, I want to stop for a second and ask if you already have questions on this first section of the working groups that we imagine come out of this workshop. Okay, so no questions to me means that everyone is really eager to start. Perfect. Okay, one more. Again, we'll retry to send that email by the end of the week or early next week with all the links if you have missed it and the reminder of what we want to do. Okay. So next up is another invitation, and I'm gonna let Rendani talk about it.
Thanks so much, Sabrina. I'm hoping I'm going to be really, really short. I am a researcher and also like academic. So what I saw in terms of the people in the room is there's a lot of work we can do together. But that's a phrase I say at every conference. It's like, yeah, what you're doing is interesting. There's a lot we can do together. But the first thing we often have to do is, where do we start? And I think I talked a little bit about benchmarking when we started, and the fact that a lot of because actually, perhaps in the AI field, benchmarks are often what accelerates progress. So where AI is today, for example, started with a data set called ImageNet. And we thought people were just being funny about it, but it was a whole bunch of images about cats, dogs. And then really the people all over the world were developing the AI models, was really just to train the neural network to recognize cats and dogs. But then then came the first sort of like deep learning revolution around, I think that was like around before 2015. And that led to deep architectures that are transformers, ChatGPT, and other things now. And the way sort of like AI developments are going in this space as well have to be driven by a benchmark, which is if I'm building my model over here, if I'm building my model over there, I need to, in our language, I guess, in the weather space, I need to have a standardized verification framework such that I can say, well, I'm actually doing better. And then it sort of creates some sort of a view of going on. So the thinking here is, we mentioned that the sort of benchmarks that are happening globally for weather, particularly medium range forecasting, are based on ERA5. And this is a This again from Weather Bench at the bottom. And our thinking is, this is probably a fertile ground for us where you could start thinking about, can we create a benchmark at least for us, such that if the AI is improving, we're really sure that it's improving over us in the sense that in our region. And the idea here is, I'm not sure how many of you guys have heard of an initiative called ENACTS by IRI? Anyone? Yeah? Yeah, Chandra. Yeah, so ENACTS is actually led by a friend of ours, Tufa Dinku, who was at IRI. And the idea there was to say, well, a lot of these models operate on a gridded format, in the sense that you want to have a complete data set that looks, that closes the gaps where you don't have observations. And then you've got your own observations over there. And the idea is you could do simple things like kriging or other blending mechanisms such that you debias the data sets. And then you have a combined view that is not just the reanalysis that we're using to create the benchmark, but is, let me call it a localized reanalysis or a localized satellite product. And the key here is, one, the approach should be one that we say, and you can always decide how much of your stations you actually are putting to blend. But again, whichever way it is, it could be 40%, 50%, or anything like that, it would still be better than having just simple plain reanalysis on it. So the idea is that we actually try and create a benchmark at least over the region or countries that are interested to participate, where we decide on sort of a level of blending that we were keen on, in the sense that and we can actually do that as research to say, well, how different does ERA 5 become if we have 20% of our station data? And the benchmark is not saying that you need to benchmark the entire climatology from 1981 or anything like that, but usually you pick a benchmarking window. This could be a period of 1 year, 2 years, or so on. That is a controlled environment where you could, which affects how these models are trained. And that will essentially, in our view, there's very little of this, not even here, but globally. Because in the global north, reanalysis is often good enough to be a benchmark. So then there's no need to sort of look at blended data sets. But then over us, it's really important that we have, as John was saying earlier on and so on, that we have a data set that is sort of, biased towards us, if that makes sense. And the idea here is to sort of, put this as research. And the nice thing about benchmarking research is that almost every other person, so basically what they do is, if anyone else is building a model, they will have to use a benchmark to demonstrate the efficacy of the value of their model. So therefore, it becomes a very lasting piece of literature. So we think this is an interesting first step that we can think about in terms of how we sort of, assess, and that again will be a good way of seeing, well, does AI really cause a significant improvement in skill over us? And this is really an interesting project. So again, as an outcome of the discussions that we had today, you could, today and before, if anyone is interested, another QR code. But this is really the different meta agencies. Some have already chatted to us saying they could be interested in something like this. But and this is, again, almost the amount of blending of your data or any data is really up to the meta agencies involved. And also, the benchmark is not public. Well, in terms of the data, your observation in terms of location XYZ is not necessarily a public data set. Essentially, it really says, somebody says, I've got a prediction here, and you can upload what your predictions are, and then at the back end, with access to your team, to the researchers that are part of the project, they actually then score the model and give them a result. So really, what the person on the other end sees is basically the scorecard. That's how good my model is, but not necessarily what the observations are, and so on and so on. Yeah, so this is again the interest form on that. Then I think we talked about this on Monday, but we're not gonna bore you guys with another session of closing remarks or anything like that. But again, if you want to continue being part of the Focus for Africa community, you can join the co-op as Sabrina mentioned. And again, the idea is to make slow steps that ensure progress in this area, in the sense that, and I think the idea is a lot of this is research driven. And I think one angle that we have to sort of think about is always premise ourselves on essentially advising our understanding of our own data, but also understanding also the efficacy of these models over us and so on. And I think that's something that I think it both builds capacity in the way and gives interesting output. I don't know how it works for the Met Services, but at the universities where I work, if I publish a journal article, the university gets additional revenue for some reason. So that's something that I think we should actually think about. We talked about collaborating, and I think on the sector use case perspective, there's real sort of thoughts on increasing the scale and impact of this work. I mean, the way we think about it is the first thing is we need to see if the models work or what we need from a technical solution perspective. And the next thing I think is this private-public partnerships that we talked about, in the sense that, because in my view is a lot of the work that we do in this space is thankless, both from the sort of responsibility that each Met Service has, but also in terms of how much the work that we do supports economic activity. And I think it's probably next phase, once we sort of bed down the modeling and dissemination perspective, to say, is there room for different revenue shares to actually make sure that the Met Services or the different units in the Met Services are getting commensurate revenue for what the value of the work that they do becomes. And I think that's something that I guess in Focus for Africa Workshop 2 could be a topic of discussion in terms of what are the different ways in which some of our outputs can be better monetized and so on. I think that's really it from the workshop perspective. I'll open the floor to questions about any things we missed in terms of next steps, any comments in terms of content that we covered over the last 2.5 days and so on. And yeah, I think the only thing after that is lunch, and then we'll take it from there. Anyone? Does anyone want to comment on the research project proposal, whether on the feasibility of it and whether that makes sense from a Met Service perspective?
Actually, I just wanted to comment on the research proposal based on the AI, the one which is very technical one.
Yeah.
So I was thinking about the modality of conducting this research over the SADC countries.
Yeah.
And I don't know which modality are we going to use, and especially in terms of the computing resources. So if we tackle this challenge, then we are able to go forward. And also in terms of the data, I think, I don't know if we are going to be able to get the observation data, the gauge observation data, so as to blend with the satellite data, especially for the precipitations. I think for temperatures is not a big issue. ERA5 is performing good. Also in terms of wind is performing good. But in terms of precipitation rainfall, I think where we have a challenge, because you put a code that if we are interested to share the data, I don't know which data, maybe some products, but for the data, because they have some protocols in Africa, so they need some cost sharing, so whatever. So maybe for the integrity issues, maybe if Forecast for Africa could just write some, maybe a letter, supporting data that we need support from, to support the data so that we can be able to implement our project. I think that can be.
I think that's a very good intervention, and I think that's you guys know what works, right? So in the sense that what are the data policies that make sense, because this is a research exercise. What is the information request type exercise that we need to go through to do this in a way that ensures data integrity on the behalf of the Met Service as well. So I think, that's actually where the team starts making input. The different researchers that are part of the project makes input onto this. And secondly, I think you mentioned about the compute. We have actually some cloud resources available already that we can actually use from that perspective.
Also, I think since the invitation is probably targeted towards meta agencies, it's worth that we mention a bit what we want to offer as a counterpart. So this is not an invitation just to submit your data and then nothing happens afterward. It's rather if you want to take part on it and share your data, which again is not actually share but publish, this will allow you access to the dashboard, for example, that we mentioned, the blending effort, and accelerate the different initiatives. I think there was a lot of talk about the budget limitation and then the sometimes difficulty into launching this really cool initiative. So we're really offering a way to accelerate this by combining with our team and our resources on the QC pipelines, the blending of data sets, and the cloud compute. So this is a way to collaborate and again, data in, tools out.
Okay, I wanted to mention that the invitations that brought us here were through our PRs. So I think it will work, especially if we try to convince them, because it looks like we are lagging behind in terms of these things. So I think it will be feasible. Things will work.
And also, there are so many things, so many steps between this form and then eventually being able to work together. Definitely, there will probably need for MOU. So this is more about the first step to register interest, and then we definitely can work together with the institutions and then discuss what can be on the table, what are the needs, and all the different options. Also, the legal frameworks that we need to go through. We're not imagining, join the form and then the entire institution is working with us. So, but don't hesitate to take this first step because we can kickstart things.
I'm going to put somebody on the spot here. Tato, you look like you've got something to say. Oh, you don't want to say? You okay? Okay, yeah, so already had a discussion with Tato. So, yeah, so I think we understand that this is not straightforward, right? So it's really, and I think that's the common ground in that a lot of the next steps that we saw even from yesterday is that there's still a long discussion on data that needs to happen. And I think one of the things, actually, as I think Rosnico and a few others were sort of putting, and I was sort of thinking about the working groups yesterday, there's value demonstration in the sense that, value in terms of capacity to actually work with these things, but value in terms of actually being able to run these things operationally on your own in your offices and things like that. And that's something that a framework that I think we still need to work together on and define, and let's see how it goes. We'll see. Ellie, you look like you're contemplating something.
Thanks, Randani. I'm trying to understand better both how the work that we're doing with AfriClimate can actually be used operationally, but also how we can make our data more useful to you. And I've just started chatting to Stephanie about this a little bit, and I'd love to have more opinions from more people around the room and just about this operational, where we're at with AI and using data operationally and using models operationally. That I'd be super interested in finding out more about that. So it'd be cool to talk more about this.
Just because I think we had the question at least 5 times, we're going to create a mailing list with everyone here. If you later don't want to be in the mailing list, you can unsubscribe, but you're going to be in it at the beginning. First, we're going to use it to share the slides because I think everyone is really keen to get the slides. And then we're going to share all the links that you saw in the presentation today, all the ways forward. And then you can, by filling the form, register your interest. If you don't fill the form, we assume you're not interested, but we try to get everyone to be able to communicate at least, and then we see what comes out of it.
That's fine. Just very simple question. In terms of structure, your forecast for Africa is under AfriClimate AI. So are you focusing only on the forecast, or do you have any other research and the collaboration areas?
Okay, I'll try and answer. Oh, Sabrina, go ahead.
We always do that. We get like one bit and one bit from that. Forecast for Africa is one of the initiatives from AfriClimate AI. We have few other initiatives. Some are funded and some are volunteer-based. For example, John, what he was presenting this morning on the benchmarking of satellite product is one of the community initiatives. AfriWiki is one of the community initiatives. AfriNet is one of the community initiatives. And then we have other funded projects that will start a bit later, but Forecast for Africa is the project we're starting today, essentially, in South Africa. So generally, they're all around weather forecasting and AI. A lot of them are also around fundamental research, accessibility, benchmarking, data cataloging. So like essentially we also try to listen to the community and support any initiatives that come out. We have this community ventures that we're starting soon, and anyone from the community who wants to do something, we can offer mentorship, sometimes some limited resources that we can make available, and the team to take this forward. So Forecast for Africa is, as of today, our biggest initiative, and probably also that's going to run for 2.5 years, but we have other initiatives as well.
Yes, so your work in hydrology and remote sensing, there is a place for that. All right. Very good. Yeah, I think then, thank you very much for enduring the 2.5 days with us. We learned a lot. We hope it was beneficial for all of you. And we wish you well for the rest of the week. Often find, the rest of the week not as productive usually, but thank you so much. Thank you for making the trip. We've enjoyed all the discussions, and I don't know if we have any other announcements. No. Oh, so it's just going to be lunch, still on us, and then the rest of the day is on you.